Hi everyone, welcome to this video on density, which is lesson 15 in the particles and energy scheme of work. This is a really nice example of how I like to teach science at Key Stage 3, and it's something I love to discuss with science teachers, especially physics teachers, because it's a topic where you can get students to achieve lots and lots of success without necessarily building that deeper conceptual understanding, which I think Key Stage 3 is all about. So I thought I'd start by showing you an example, and this is the way I often see density taught, and there are definitely benefits to this, and we probably have to teach it like this when we get to Key Stage 4. What I want to show you today is how I think we should teach it at Key Stage 3 and why that is. So what I often see is this. Examples like this. An object has a mass of 20 kilograms and a volume of 0.5 meters cubed. Calculate the density. So we show students this equation. We say, well, okay, density is mass over volume. Depends on these two things. Density is 20 kilograms over 0.5 meters cubed. Therefore, the density equals 40 kilograms per meter cubed. And that's all fine. The students do lots of examples and they plug the numbers into the formula, and everyone goes away happy. The teacher sees success, lots of writing in the students' books, really satisfied that they've gone away and they've practiced density in the way that they wanted to, and the students feel really happy that they've got to put lots of ticks in their books and they've got all the right answers and so on. I guess my point is here, if we were to swap some words around like this, so we said an object has a red of 20 kilograms and a blue of 0.5 meters cubed. Calculate the green, and we gave them this formula, green equals red over blue, and we might need to tell them that green has the units kilogram per meter cubed, red has the units kilograms, blue has the units meters cubed, and so on. They would follow the exact same process. They would put the numbers in, they would get the answer out. You can see I got it wrong first time, so I wouldn't get the green tick, but I did correct it. The point I'm trying to make here is they've followed the exact same process that we've guided them through, but actually I've substituted what is a meaningful equation, which depends on these ideas of mass and volume and how they're related. I've substituted that with a completely nonsense equation, a meaningless equation. But is there that much difference for the students? Because if they haven't really got the idea of what mass is and what volume is, when they plug those numbers in, you could use the words green equals red over blue, and they would just be plugging the numbers in and pulling the answer out without really there being any difference between that and what they do with the density equation and so on. So this is why I avoid doing maths, certainly algebra and rearranging equations and so on, as far as possible at Key Stage 3, because what I really want to do in this lesson is build a deep conceptual understanding of density, so that when they get to Key Stage 4 and they are going to use the equation, which is a massive shortcut, they have a sense of what that equation actually means. So the two examples I like to use for explaining density to Year 7 or Year 8 students at Key Stage 3 are to do with gold and chocolate. And I don't know why I chose these two examples. Well, I kind of do, and there's a video actually in the slides, which is an example I heard from my mum, who went to South Africa, and she was invited into a gold mine. She used to work in the kind of metals sector, and the person at the gold mine said, "Oh, by the way," at the end of the meeting, "by the way, that bar of gold over there on the table," which was, you know, this sort of big, not a particularly big bar of gold, if you can pick that up with one hand, it's yours. You can take it away. Now, I don't know what that would be worth, but obviously thousands and thousands of pounds. And the trick is that it's so dense, gold is such a dense material, that no one is able to pick up a bar of gold just with one hand without having any sort of device to kind of lift it up. So that's a nice example, and I use that for students. I tell that story because it gives them a sense of what we're talking about here. And then I've got to somehow get them to think about that and explain it under the visualizer. And what I do is compare the bar of gold, and I get them to imagine a bar of chocolate, which was the same size, or we should really use the same volume. Now, what I would do then is draw two side-by-side diagrams like this. And this is a tricky one to explain, because in the past I've done it by trying to show the particles more spread out. So you might say, okay, in chocolate the particles are more spread out, less densely packed, let's say, than the particles in gold. But you do get to all sorts of I found myself in the past getting into all sorts of difficulties. So the way I did it second time round was as follows. And I just said, well, okay, let's just assume that the particles of gold and the particles of chocolate are roughly the same size. So in each one of these, let's imagine I've just got a certain number of particles like this. And I'm just going to draw, and I keep it really simple, let's say 2 rows of particles. And I can remind students that it's solid. So they're in this kind of fixed lattice. You could draw them jiggling and stuff if you want, but that's not really what we're focused on here. And what I want to show, how many have I got here? 14. So what I want to show is that I've got, ideally, your diagrams will have the same number of particles in each bar, the bar of gold and the bar of chocolate. And I should really label these diagrams as well. So what you want to do is show that because they're the same volume, they've got roughly the same number of particles. And this is not a perfect count, but hopefully it gives them a sense. So let's say this is the gold and this is the chocolate. If they've got the same volume, well, what's the difference? So what I do is say, well, actually, and usually by this point students haven't studied the periodic table, so they don't know about atomic mass and so on. But I can just tell them, well, actually, it turns out that each particle of gold has a mass of 100. And I don't even need to use any units, let's just call it 100. And I'm making these numbers up. This is just to illustrate the point. Whereas each particle of chocolate, if that was a thing, obviously chocolate is a complex compound, but we'll just say, to keep it simple, to illustrate the concept of density, well, each particle of chocolate has a mass of 1. So what this means is, if I've got 14 of these particles, each with a mass of 100, and I shouldn't have put grams there, sorry, I've just realised. I'm just going to keep it arbitrary units. Well, then my total mass will be equal to 1400 of whatever units I'm going to choose. But in this case, because I've got 14 but each has a mass of 1, I'm going to say, well, my total mass equals 14. So clearly this one, and I might do this in a different colour, clearly this one has the greater mass. And students don't find this difficult so far. If I've got a greater mass in the same volume, what that means is this one is more dense. And this one therefore must be less dense. And what you'll see in the slides is students have an opportunity to try and explain this, and just giving them a simple account of density in terms of particles, because this whole unit is based on this big idea, this concept of particles. That's a really nice starting point. And that's a simple example that students won't find too difficult. They'll be like, okay, I can see why if you've got the same volume of gold and chocolate, well, the gold is going to have a greater mass because it's more dense. Where it gets difficult for students is when they have to think about 2 objects of the same mass and which one is bigger, which one is smaller. And they'll probably get that wrong, because the misconception here is, well, if it's got a bigger mass, it must be a bigger object. But of course, the more dense material, if the 2 objects have the same mass, the more dense material will be smaller, because that mass is packed into a smaller space. So I might go about illustrating this as follows. So in a similar way to what I did before, I might say, well, okay, let's say our 2 objects have a mass of 1,000, or you could say a kilogram. Let's say our 2 objects have a mass of 1,000. Well, our gold here, over on this side, would just have and I've not drawn this perfectly, hopefully you see the point here. If each particle has a mass of 100, then in this case, my mass equals, just got 10 times 100, which this is the extent of the math that I do in this lesson. Students hopefully are happy with the idea that that would be 1,000, okay? But then I'm going to refer back to my chocolate particles and think, well, okay, if I wanted to get a mass of 1,000 here, I would need a really big object because I would need 1,000 particles inside this object. Now, I'm not going to start drawing 1,000 particles, or I'm not actually going to draw 1,000 particles. I'm going to start, but as long as I kind of do a couple of rows, something like that, and then maybe do a dot, 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 hopefully they get the idea that if each of these particles has a mass of 1, then I'm going to need 1,000 particles, not just the 10 that I had in the gold, to get my mass equal to 1,000. Now, the conclusion I can draw out from here is that if I've got two objects with the same mass, but one is more dense, i.e., this is given definition of density in terms of the mass of each particle, and that's the idea that we want to draw out here. What that means is this will have a smaller volume, this will have a larger volume, and the idea that I want to get across here is if I've got the same mass in a smaller volume, that's another way of saying an object is more dense. So this is the bit they find difficult. Now when we do get to doing calculations, I like to draw all sorts of other diagrams without the particles, but that maybe comes later at Key Stage 4. For now, I find this is quite a nice introduction to density, building on the idea that matter is made up of tiny particles that we've introduced all the way through this scheme. And yeah, I think the key point here is the key takeaway. This is a way of explaining density in terms of what is the mass of each particle, and really highlighting this difference, that the reason gold is more dense than chocolate, for example, whether they've got the same mass or the same volume, the reason gold is more dense is because each of its particles has a greater mass. And that seems to me to be the most important thing that students can take away from this lesson.